All right, so one of the very last things that we did before the break and the final and everything was synthetic division. So we're going to talk about synthetic division more today. And another thing that synthetic division provides us, beyond just the ability to help us divide really quickly without long division, right? So for your warm-up, I want you to use this function right here, x to the third minus 4x squared plus x plus 6, and you're going to just do 4 different synthetic divisions. So boom, 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 boom. You'll notice I'm giving you the root, not the factor, the root. X equals 3, so 3, not negative 3. You don't flip the sign if it's not a factor. If it said x plus 3, then you would put minus 3. But it's not giving you a factor, it's giving you a root. So you put the root, and then you put your coefficients, and then you multiply, add, multiply, add, multiply, add. Okay? I'll kind of go through this first. It's been a while. I'll go through this first one with you, and then I'll ask that you do the rest. And then if you finish before other students, you can just kind of look at the graph, right? Because I provided a graph of this, and I didn't say why, because we don't really need that. And see if you notice anything about your synthetic division results and the graph itself, okay? Because the graph is of the function that we're going to be doing, right? So, and that function, I'll write it again down here so we don't have to keep scrolling. That function is f of x equals x to the third minus 4x squared plus x plus 6, right? So if I'm doing synthetic division, well, and I'm doing 3, well, the question I'm really asking myself here right now is, what is x to the third minus 4x squared plus x plus 6 divided by x minus 3? That's the question I'm answering when I do this synthetic division. And my answer will be down here, kind of, but it'll tell me what my answer is, right? So remember, to set this up, we just pull our coefficients, right? So our coefficients are 1, because when there's none, there's 1, negative 4, 1, and 6, right? So 1, negative 4, 1, and 6. Now, we always check if we're going from highest exponent to lowest exponent without skipping, meaning I have x to the third, x squared, x to the 1, even though there's nothing there, and then nothing, right? So that's good. 3, 2, 1, nothing, right? If there was one missing, like if it went x to the third and then skipped x squared, I would need to know that because I would need to put a 0 in that spot, right? But we're good on this one, right? You're going to see one later that does have that missing piece that you'll need, okay? So the first thing I do is just write these numbers. 1, negative 4, plus 1, and 6. In fact, writing a plus and minus on each one cannot hurt, okay? Now the other thing I do is under that last number, I make a box so I remember that's my remainder. That's not really part of the answer. Well, it's not part of your equation answer. It's a remainder answer. Okay, first thing I do is I just bring down that first number, right? So I have 1. And now I go into a multiply, add, multiply, add, multiply, add mode, right? I multiply by this 3, and then I put that number and I add. So 1 times 3 is what? 3. Negative 4 plus 3, negative 1. 3 times negative 1, negative 3. 1 plus negative 3, negative 2. And negative 2 times 3 is negative 6. And then 6 plus negative 6 is 0. So what did I just find out? There's no remainder, meaning that, yes, this is a factor. So this means x minus 3 is a factor, right? And that means that 3 is a root, and that root is an x-intercept, right? All of that is what we know when we get a remainder of 0. And my answer to this question, right, this question of what is this divided by this, is then these coefficients put back into an equation. So it would be x squared minus x minus 2. And no remainder, so I don't have to do like plus 3 divided by x minus, something like that, right? We'll see examples today where you do. But this one, this is my answer here, right? This divided by this is this, right? Does everybody see how I got from here to here? If you don't, let me know. 1x squared minus 1, minus 1x, minus 2, minus 2, right? 3 terms, so it's x squared, x number. If there were 4, you would go x third, x2, x1. No, none. Okay, so there's your little review of synthetic division. Now I want you, if you haven't yet, to do the other 3. And again, if you finished, I want you to see if you notice anything about the graph and your synthetic division, even the ones where you didn't get a remainder of 0, okay? And then we'll share out what we noticed, okay? Give you some time. All right, so hopefully you had a chance to do those. If not, keep going. I'm going to start putting them up on the screen, okay? All right, so hold on. All right, so this next one, x equals 4 is my root that I'm testing, right? So that means the factor that I'm dividing by is x minus 4, right? So I'm asking the question of what is that first polynomial divided by x minus 4. And to answer that question, I do long division, right? Not long division, synthetic division. And I put the root, or the possible root, right? I don't put the factor, I put the root. And then I put those same coefficients in. 1, negative 4, 1, 6. Okay? Put a little box for my remainder. Bring it down. And then it's 1. 4 times 1 is 4. Minus 4 plus 4 is 0. 0 times 4 is 0. 1 plus 0 is 1. And then 4 times 1 is 4. Add them together, you get 10. Okay, so my answer to the question, what is my polynomial divided by x minus 4, would be x squared, and then plus 0x plus 1 plus 10 divided by the factor. So if you do have a remainder, you have to write the remainder divided by the factor. Okay? Now, is there a simpler way I could have written that? Yeah.
Couldn't you have done x squared plus 0x plus 3 plus 2 over x minus 4?
Plus 3 plus 2. Where are you getting the 3 and the 2 from?
Can you pull 8 from 10 to get 2 groups of 4?
No, because you can't divide that. 10 divided by x minus 4, because that's a group on the bottom, you can't divide it. Yeah?
Just to say x squared plus 1 plus
So 0 times x is nothing, right? So really, the most simplified version of this would be x squared plus 1 plus 10 divided by x minus 4, because I don't need 0x, right? Okay. All right, so that's the answer to that question. Let's keep going. Oh, so was x minus 4 a factor? No, it wasn't. And that means I don't have a root at 4. Okay? I don't have an x-intercept at 4. All right. Here we got negative 1. I'm going to start to go a little quicker. Couple reasons. One is to show you how quick you can do these. And then 2 is so we can get to the point. All right, you bring down the 1, multiply, get negative 1. Add, get negative 5. Multiply, get 5. Add, get 6. Multiply, get negative 6. And it gives me a 0 remainder, which means this is a root and x, and then the factor would be x plus 1, okay? because we got 0, so we have no remainder. We know it's an x-intercept, right? We know it's a root. And the answer to the question would be x squared minus 5x plus 6, no remainder. That's my answer. Questions? All right, one more. We got 1, and then 1, negative 4, 1, 6. With a little box, bring down the 1. 1 times 1 is 1. Add, you get negative 3. Multiply, you get negative 3. Add, get negative 2. Multiply, get negative 2. Add, get 4. So the answer here would we get x squared minus 3x minus 2 plus 4 over x minus 1, because that would be the factor that would go with it, right? Though we know it's not actually a factor or a root. Okay. All right, so we're all practiced up with our synthetic division. We've seen a couple different types of examples. What did we notice? Yeah, Hannah.
I noticed that on the graph there's a point at 4, 10, and 1 for which is the numerator on the remainder.
Anybody want to add to that? Yeah.
I got that when, wait, we're saying, when,
Is there a rule you've discovered?
yeah, when there's no remainder, it's like attaches to its point on the x.
When there's no remainder, we have an x-intercept. And then when there is a remainder, there's no x-intercept, but there's something.
The remainder is at least a point on
Exactly. Take a look.
makes
Take a look. Yeah. Why? Go ahead.
which makes sense with x-intercepts because why would you write out 0 over x?
Yeah. So think about what an x-intercept is. It's a point, right? A point that always has a y of 0, right? So if we look on the graph at our x-intercept, this one, well, the point is 3, 0, right? Okay? Now, this is the key. We use synthetic division to divide, but there's also an added benefit to it because it actually gives you outputs for your inputs. We didn't realize that when we kept getting 0 as a remainder, but it was telling us the y, right? And we can prove it, right? Here, we tried 4. It didn't work out. We got a remainder, right? But if you look at the graph at 4, what do you notice? It's 4, 10.
Your input next to your output is a point.
Yup. So you asked early on, why do we have to do synthetic division? Because it's got some benefits, right? When you think about when we had to get x's and y's before, we had to plug it in over and over and over again. Now, if we're good at synthetic division, we can do it pretty quick, right? Let's keep looking. We got negative 1, 0. Well, that must be an x-intercept. And sure enough, it is, right? Negative 1, 0. And then this one was 1, 4. And then if we go here, we have a point at 1, 4, right? So every time we do synthetic division, it's worth it, even if we didn't find our root, because we got a point out of it, okay? Does that make sense? That's the key takeaway today. All right, so let's sum it up a couple different ways. So first of all, if your remainder is 0, you have a root, or in other words, x-intercept. We knew that. We're carrying that forward. But the new thing that we know is if you divide and get a remainder that doesn't equal 0, you have a point. So still worth doing, right? So you'll get an xy where x is the number you divided by, and y is your remainder, right? It's going to be very useful in a couple different times, a couple different ways, okay? So there's this called the remainder theorem. Anytime in math there's like an absolute rule that we can just use over and over again. It's a truth, it's good. We use the word theorem, right? And this is called the remainder theorem, and I'll give you that now, the formal definition per se. We're going to put that at the bottom, okay? So your remainder theorem states that if you divide a polynomial by a given x value, your remainder is its, big word time, corresponding. Everybody know what corresponding means? They go with each other, right? Corresponds with means goes with, right? It's its corresponding y value, giving you an xy point on your graph. And it doesn't just give us that. I mean, it does give us that. But important thing to note is it gives you an output for any input. And why do I make the point of saying it that way instead of just saying a point on the graph? Because sometimes we don't have a graph, right? Sometimes I'm just asking you for an output with an input, right? Which brings us to our next page. So when you're done writing that down, you can go to the next page. So for example, what if I gave you this, and I said, hey, evaluate the function, meaning evaluate means find the value of, right? And it says find f of negative 2. This is something that I think we tripped up a little bit on the final. Some of us forgot what that even means or what it's even asking, right? So good time for review. When I say find f of negative 2, I'm giving you something and I'm asking for something. What am I giving you? The x, right? The input. This is, we're given our x value, which is our input. And anytime you're given an input, what do you think they want? We want the y value, the output. Right? So f of negative 2 is saying, hey, when x is negative 2, what's y? Right? What's your output? Right? And the old way to do that was what? You got to plug it in. So you'd have to go f of negative 2 equals negative parentheses. And boy, do we make mistakes with those parentheses sometimes, right? So negative parentheses, negative 2 to the third plus 4 times negative 2 squared minus 2 times negative 2 plus 8. Right? So we would either work that out, or if we had a calculator, we'd plug it in, be super careful, don't make mistakes, right? But it's easy to make mistakes with that, right? The new way is synthetic division, right? So if you need to find an output and you're given an input and you have a polynomial, you can use synthetic division, right? I test that value of negative 2. negative 2, right? And my coefficients are negative 1, positive 4, negative 2, and 8. And then I have my little remainder box, and I do my synthetic division. Okay? Bring down the negative 1, multiply, get 2, add, get 6, multiply, get negative 12, add, get negative 14, multiply, get 28, add, and get 36. All right? Now, we just did synthetic division, right? But we didn't do it to find this part. We did it to find that part, right? The remainder is actually what we're really interested in this time, right? So be careful when you get these questions that you answer the question that's being asked. So students last year on the quiz, they remembered what they were supposed to do, right? And their answer was negative x squared plus 6x minus 14. That's not the question that's being asked, right? That's an accurate statement to the division. But I'm asking you, what is f of negative 2? And you need to give me the output for that input. And we learned that you can do that by looking at the remainder, right? So when you do this, you should be able to make the statement. So I know the graph has a point at blank. What? Negative 236. Right? I know that by just doing synthetic division. It has an input, so f of negative 2 is 36. Okay? So this is one scenario where you might use this tool, right? Because this might be way easier and quicker and less mistake prone than this for you. Okay? What's your question? What was that? Okay. So that's one scenario. Another scenario. Yeah, question.
But can we use the old way?
You can, but, well, unless you're told in the question to use synthetic division. But it's going to take you a lot longer. Okay. Typically it takes students longer. Typically, once students get this, they can, because here's what I mean by longer. What if you don't need to do just 1 point? What if you need to do 5, right? So that brings us to our next one, right? We want to graph this whole thing, right? So when we talk about when we don't have any other way to graph, we make a what? Table, right? So I'm going to say, okay, I need points, right? I need inputs and outputs to put on my graph. So I go, okay, well, let me just go negative 2, negative 1, 0, 1, 2, and plug each of those in to get my y. But now you don't have to. Now you can do synthetic division, pull the remainder, you'll have every one of those output values, right? Now, that's going to give you points on the graph, right? These are still polynomials, so we still want to answer those 3 questions before we graph. What's my degree? Am I even or odd? And does it reflect, right? Between these 3 questions and the points that you're going to get from synthetic division, you're going to have a real nice graph. So remember, earlier on I said, hey, give me the end behavior, get that right, and the squiggles in the middle I don't really care too much about. Well, now the expectation is now going to be a little higher, because now you have the ability to get these points to really shape your graph in a nice way. Okay? So you would say, okay, I need to know the output when x is negative 2. Let me use synthetic division, and you're going to do a bunch of synthetic divisions, right? You would do negative 2, and then you have x to the 4th minus 4x squared minus x plus 4. Anybody notice anything? What's the first? What do we always check before we do synthetic division? Yeah. Yeah, there's no to the 3rd, right? We got to imagine there's a 0x to the 3rd in there, right? If we don't do that, we're going to get really weird answers, right? So what I put into my synthetic division is 1, 0, negative 4, negative 1, 4. And I'm mostly just interested in that remainder, right? So I bring down my first number, I go from there, I get that value, that goes in my table, that point goes in my graph. I add a bunch of points, then I think about these questions, and that helps me with my end behavior, like where do I begin, where do I end, and then I'll have a nice graph, okay? So I'm gonna let you work on that for a little bit to try to get some points, get going. I'll come back to you in a couple minutes or a few minutes with what it should look like, and I'll hand out your homework while you're working, okay? Any questions before I? Okay. Another nice thing about synthetic division versus the old way is you don't really need a calculator for the most part, right? So I can tell you no calculators and you'd be okay, right? Because most of it's just adding and multiplying. Pretty small numbers, right? Yeah, question?
Should we do 3 and -3?
You don't need to, because the end behavior will answer those questions for us, okay? You could if you wanted to test it, but you'd see it's way off the graph. Okay, so if I did this, I bring down the 1, -2, -2, 4, 0, 0, -1, 2, 6. So I have a point at -2, 6. And you would do that every single time. So you'd have a bunch of synthetic divisions on your paper. And if you did, you'd get -1, 2, 0, 4, 1, 0, and 2, 2. So you can add those points right to your graph. -2, 6, -1, 2, 0, 4, 1, 0, 2, 2. Now, the other thing you got to keep in mind are the things that we have already talked about that have helped us graph in the past, right? Before we had points and we were just worried about like kind of the end behavior, right? So what's the degree of this function?
4.
It's 4, right? And is that an even or an odd number?
Even.
It's an even. And does this thing reflect? No, there's no negative out front, okay? We know that even functions that don't reflect start at the top and end at the top, right? Just like a parabola would, okay? So that helps us. We start at the top, we'll go through our points, we'll end at the top, we'll be good, right? Now, you asked a question about, well, should I test -3 and should I do 3? It can't hurt. If you did, you would find that the numbers are way up here, and that would just tell you the story too, right? Tell you where to begin and end, right? So you come down, go through the points, and we have a pretty good graph here now, right? Because before I was just making little squiggles in the middle. Now I know exact points. I got my y-intercept nailed. I got my x-intercepts nailed. I'm in good shape, right? I've made a much more accurate graph, okay? So that's your task on your homework, is to practice using synthetic division to find outputs, whether to graph or to just answer that question, what's the output? Okay, any questions? Good job getting through first day of second semester.